Alright, so if you're given the scenario where they have two forces acting on an object, and they ask you, what would be the total force felt by the object? Would you be able to solve? If not, continue watching this video. So, we can start by identifying a fundamental characteristic of forces, and that's that any number of forces acting on an object has the same effect as a single force equal to the sum of these forces. But what does this mean? This can be better illustrated visually. Draw two vectors, F1 and F2. The resultant vector is going to be the sum of these two forces, and we can draw it as so, where R is equal to F1 plus F2. The two forces F1 and F2 have the same effect as a single force R acting on the object, as you can see in the diagram. But we can generalize this by writing the R vector as the sum of all forces. This is a fancy way of saying F1 plus F2 plus F3 dot dot dot. And we can break this down in terms of components. Resultant vector in the x direction is going to be the sum of all the forces in the x direction. So f of x1 plus f of x2 dot dot dot. And we can do the same thing for Ry. And then the resultant vector is going to be equal to the resultant vector in the x plus the resultant vector in the y direction. And then we can use the Pythagorean theorem to find the magnitude of the R vector by just doing Rx squared plus Ry squared square rooted. So with all this information, we can bring it back to our example. We can start by identifying a coordinate system. So we can use the x and y direction, represent F1 as 5 newtons in the y direction because it's pointing that way. And then F2 is going to be 3 newtons in the x direction, like so. Apply our equations. For the sum of the forces in the x directions, we get 3 newtons x from the second force, and we get 0 newtons from the first force. And then for the Ry direction, we get 5 newtons from the first force, and we get 0 newtons from the second force. These are our resultant vectors here, and then we can represent R as Rx plus Ry, and we get this here. So this represents the force felt by the object, but we can find the magnitude and direction to draw this vector physically. If we use our magnitude equation here, which is just the Pythagorean theorem, and then plug in our Rx and Ry values, evaluate this expression and get the magnitude equal to 6 newtons. So this is going to be the magnitude of our resultant force, but what is its direction? To find this, we can use trig. This is our resultant vector here. Draw this resultant vector like so. We can see that this angle theta is going to represent the direction with respect to the horizontal. Sine theta equals to opposite over hypotenuse, and opposite to theta is going to be this number here. And then we can see that hypotenuse is obviously going to be this because it's the largest side length. Plug that in, isolate for theta by taking the sine inverse. We get this answer here, which is approximately 56.4 degrees. And so this is the angle with respect to the horizontal that the resultant vector points in. So we can draw this now physically. If we draw our force in the y and then our force in the x, we can see this is going to be a resultant vector equal to 3 newtons x plus 5 newtons y. And this is our angle theta we just solved for.